Okay, good morning, everyone. Apologize for the little delay here. Today, I'm going to talk about a topic, blockchain, and how do we apply blockchain to storage system supply chain. But before I move on to the topic, I talked about this presentation in a more shorter version at last month's Flash Memory Summit. And acquaintance of mine there, Tom Friend, you're in the audience. He actually invited me to come by, oh, there you are, to come by and speak on this topic again here. So thank you for the opportunity. And quickly, of course, I won't lose any opportunity to hopefully share information about what I'm working on. But little that I know afterwards, I said yes, that this is a conference created by developers for developers. So I went back to my material and tried to make sure the audience here will have the right expectation of the content that what am I going to talk about on blockchain. Because when people talk about blockchain, there's so many different type of blockchain out there, and there are so many different perspectives of blockchain that people might be aware of. So that's me driving the car. Knowing how to drive doesn't mean I know how the engine in the combustion reaction work to move the piston, the cylinder, the car moved. I use the internet, I shop, and I use it for like GPS and all other reasons, but not necessarily that I know how the TCP/IP protocol underneath works. So I would like to make sure everybody understands the perspective that I'm talking about blockchain is from a more user perspective. So I won't go into topic of like consensus mechanism that some developer might be excited about in terms of computer science perspective, or how the hash is going to be working for block to block and making them immutable, that kind of a conversation, but more from the experience that I gained in the past 1.5, 2 years in this space. I used to work in tape storage, and I'm very happy to meet Dr. David here, who retired from Almaden Research, who he actually worked in the tape storage world. And I used to do a lot of failure analysis on the magnetic head and do a lot of manufacturing control, making sure that there's no electrostatic damage to the sensor. So it's a very different world that I'm at today, talking about this topic. So there are many organizations in IBM. As everybody knows, it's a big company. We're over 110, almost right, years old. And we have organizations working on blockchain in the open source community perspective. We participated, contributed a lot of codes in the Linux Foundation on the Hyperledger fabric layer. So we have a group of people dedicated the whole time to do that. We have people dedicated time to work on the IBM platform, like blockchain platform, laying on top of the fabric layer. And also we have our global business service team working hard on working with our client using the IBM blockchain platform to help them to solve problems. So I'm now in a supply chain, which is a totally different organization. We're the only hardware organization left doing mainframe, power, and Z storage, right? So I'm in that umbrella and doing supply chain engineering. So one thing we try to do looking into blockchain is like, as a user, right, not like a vendor for blockchain technology, how we can adopt this into our supply chain to harness the benefit of it. So today I'm gonna quickly go over blockchain basics on terminology. There are different types of blockchain out there, like I mentioned. I wanna make some clarification on the different terms and then frame into the blockchain technology that I'm using to help my organization. And also go through some exercise on like what is considered a good use case of blockchain, because not everything can be blockchain. So as you can see from the beginning of this presentation till now, I've been already talking this word many, many times. And so as out there are a lot of like hype out there using blockchain. And then I'll go into more of a specific type of blockchain, which is only designed for business. And there will be 2 examples I'm gonna give out in terms of successful use case that's happening and developing. And then at the end, I will wrap up with the closest use case that I'm working in, which is working closely with a storage supplier to apply the technology to help us solve our pain point. So why do we need to care about blockchain, right? Like it's a hype word to some people. So here are some prediction statistics coming from some reliable sources like World Economic Forum, Gartner, right? And we have organizations dedicated to do a survey from IBM. So we're predicting their 10% of the global GDP will be stored on blockchain by 2027. And then the value add of blockchain onto our business will be by 2025, it's predicted to be about 176 billion. And it's like also going to be exceeding like 3 trillion by 2030, which is like all this huge number, astronomical number. There's another prediction for my company, right? By next year, there should be more than 50% of the bank that will expect to have some sort of application is underpinned by the blockchain technology that you will be using. And then by 2021, the blockchain technology itself as a market will go to 23 billion. So this is something that I think we need to be aware of, that is coming, just like back then when we're not aware internet is going to be like as pervasive as today now. Traveling back to time a little bit on the history of blockchain, how it's being developed. So I think it might be well known that in 2009, there's this person or he or she or a group of people, mysteriously, we still don't know, I think we still haven't found out, Satoshi Nakamoto created an application underpinned by blockchain, and that application everybody gonna know called Bitcoin. But he's not, or she is not, or they are not the only the people who came up with this idea. Actually, the technology itself can be broken into two elements, right? One is the cryptocurrency, the digital currency of Bitcoin. The other one is the blockchain technology on its own. How do you create transaction in a block with a hash that is actually referenced back to the previous block? And those concepts are actually already introduced back in 1991 by Stewart Haber and Scott Stranada. They actually first introduced about the chain of blocks in cryptography. So they are the one who inspire the work that comes out in 2009. And now they have been kind of like recognized as the father of blockchain. Another piece is digital currency, right? So Nick Szabo actually already coined that term, digital currency, back in 1998, which is 7 years after Stewart and Scott. So all this technology already kind of in bake back then. And with Satoshi Nakamoto's work, he put it concisely together and put it into a white paper and published it. And that's what created blockchain. So at that time, everything like skyrocketing with the Bitcoin price and everything, but along with some not so good social media comes with it. Financial market have a lot of proof of concept actually started with this technology coming to be more visible. And all of this become calling the first generation of cryptocurrency blockchain. But then in 2014-15 timeframe, there we have a very young genius. His name is Vitalik Buterin, who I think many of you might have known. If you haven't seen him or see him on YouTube, go Google him. He's extremely extraordinary. He's being compared to Elon Musk and compared to Bill Gates and all of those people, but he's only 19. He founded Ethereum, another blockchain technology with a cryptocurrency application, but with the features of smart contract. So that's being recognized as the second generation of cryptocurrency type of blockchain. And since then, right, in 2015 and 16, that's when the blockchain that I wanted to focus on come along, which is many big companies like IBM, Microsoft, work together under the Linux Foundation and established a project together, the Hyperledger project with 6 frameworks underneath. One of them are the Hyperledger Fabric and also 8 tools being like co-developed together. So the work that I work on with my supply chain and partners are they're all focused on the blockchain in the Hyperledger Fabric as the underpin layer. So that's a quick history of blockchain. So now let's come to clarifying some terms of blockchain out there. You might hear people talk about public and private blockchain. Some people talk about closed and open, and permissionless. Each of them might sound similar, but they're actually also mean a little bit different in terms of the nuance. There's actually have a little different definition. For example, when people talk about public versus private blockchain, they're really referring to who is able to write data onto the blockchain. So if you're a public blockchain, everybody can write on it. If it's private, there's a limited number people with identity in the network can write on it with the right role also. Closed versus open is more referred to who can read the data on the blockchain. So it also meaning like if it's closed, right? Not everybody can have access to see on the ledger. Permission and permissionless is more referred to the platform on its own, like what is a user privilege. If it's a permissioned blockchain, so that means not everybody can join, not like Bitcoin or Ethereum. They're more like divert into the talking of like Hyperledger and R3 and Corda. So on the right-hand side, there's some example of the different type of combination of this public open, public close. But basically, you can see that Ethereum and Bitcoin are more tied into the currency use case, public open. Anybody can write it, anybody can see the data on the ledger. Versus the private and open, and I'm in the supply chain, so I'm very focused on working on blockchain platform that can be able to have a limited people that we know with identity to work together as a business network. And also the data, although we wanted to work together with known people, the data that we put on, we do want to have people to be able to see it out in the public. I will give some example later on that will represent this quadrant very well. So we cannot not talk about the hype cycle because it's really a hype word in blockchain world. So Gartner's has this proprietary graphical representation of hype cycle, right? They divided that all the emerging technology into different phases. They have one for IoT, they have one for different technology or ML, machine learning, AI, like Eric mentioned earlier, really hesitate to put AI on. But so I wanted to put it there because just wanted to give a sense of where we stand in terms of the technology right now. This particular one is about blockchain business. This being published this month, actually. There's another one is for only the blockchain technology, but it did have included some of the technology element in this graph already. So they divided into 5 phases, and the innovation trigger is really back in the Bitcoin timeframe when people hear about blockchain. Everybody just jumped to do something about it. There are investors putting money without knowing what is the return of ROI to it. So a lot of expectation, but at this phase is really no real product at the first stage. And then as time goes on, it goes into the peak of the inflated expectation, meaning the POC started, and then people starting to realize not all the POC or proof of concept they invested in are actually suitable for this technology, or they're really not even necessary to use blockchain. So you will start to see dropped out of project. You might hear them have a huge media presence at the beginning, and then there's nothing after like a month or so or 3 months down the road. So POC start to die out in this stage, and people's interest is like starting to wane, and people are turning away from the technology. And the trough of the disillusionment, basically it's when you have a good use case, really suitable for using that technology, they will stay. And the one that's bad will die out here. And the one that stay on eventually will climb out of this trough of disillusionment and go into the slope of enlightenment. The slope of enlightenment is really when the good ones starting to build more momentum, and they're starting to see the reason that they use blockchain is gaining really some benefit to their business, and they then be able to grow their network and then eventually go into the plateau of productivity. We have some project like that already went through like multiple cycles, but in general, for blockchain as a technology overall, we are actually still at the early phase. According to the Gartner report, we are at around this trough period that you will hear a lot of POC is failing, and so there it's an expectation that we're going to climb out from that in 2 to 5 years, which is that blue circle is representing. So 2 years or 5 years, really nobody knows. And it could also never be able to get out of that as well. So that would need to be keep monitoring what is the report coming out in the future, see what the survey might be saying. And for the blockchain and supply chain, right, we are actually at this peak of the expectation, inflated expectation. So if you keep track of the media, the press release, there's already a lot of POC that started with a lot of a promise. It's already disappeared. There's no more follow-up on that. So luckily, the project that I'm working on today is still moving on to the next phase. So I would like to share it with all of you, some lesson learned, and hopefully it might be also applied to your developer world, maybe. I'm not too sure. So we talk about some good use case might stay, some might be just disappear. So what really make a good blockchain use case is actually very simple. You really need to have a problem to solve to apply blockchain and a real business problem. But then that real business problem really need to be evaluated closely that you don't have any alternative solution to it. Because a typical distributed ledger technology can maybe do the same thing. You really don't need this type of blockchain as a distributed technology to solve the problem. And then once you have the problem identified, then you'll be able to identify surrounding this pain point you have, who are the stakeholder who needs to be involved to create that business network. Then you can identify the participants, what is the asset you try to put on the blockchain, and then the transaction. And then at the end, whatever you're building, that solution, you really need, that solution would need trust. If you don't have a solution that you really need trust, you might be able to find alternative technology to help solve that problem. Because at the end of the day, blockchain is really to provide the 4 quality of services, which is the consensus, immutability, finality, and provenance to your problem. And after even though if you'll be able to get all the use case in your business together, right? You were able to figure out, I can try blockchain on this use case and that use case. You still need to limit it to find out what is the first use case you want to do. And to find out that first use case, you need to make sure that it's a very limited scope because you don't want to boil the ocean with the first project you have. And then making sure it's a small business network. And then, as you build out a solution, also need to make sure that this blockchain product you're making at the first phase have a way to include more participants afterwards. You need to have more scenarios open up, just in case more features that you need to build into that platform can be done as well. So that's the way that we have done to follow to build the project that we're doing. Basically, we will follow the MVP, pilot, and production. So at the very first stage, we're very carefully have design thinking workshop come together with the business network participant and figure out what we wanted to do, and we move on to pilot after we demonstrated that we do have the right technology to apply for the problem. So this is basically just summarized, right? The 3 golden rules. You need to have a problem, you need to have the right business network, and you need trust for that network. So now let's go a little bit into the business network. How does it look like before blockchain and after blockchain being applied to a business network? So here I'm showing on the left-hand side, there are a traditional business network that we're dealing with every day in a supply chain. Maybe I would say it's more specific to my use case. So there are 6 participants in there, and each of them will maintain their own ledger. So a ledger is basically a transaction log, right? They are recording the change of ownership of an asset, let's say a storage or a flash drive, hard disk drive, and then so they keep that asset flowing into and out of your business. And this network is very inefficient, the traditional way, because the transaction is managed point by point, from point to point, and each of the point-to-point transaction has their own business rule to apply. So your ledger might look different from my ledger, also with the time latency and everything into it. Plus, it's a very vulnerable network because if one participant had a compromise by like a cyber attack or even a mistakes being made, it will be it will compromise the whole network. So, so if you once you apply blockchain to this network, you change basically the whole way it works. You are having a shared ledger, so all the participant is actually seeing the same transaction because, as I mentioned earlier, one of the quality of service provided by blockchain is consensus. Each participant in this network need to agree on this transaction can be written onto the blockchain, and they need to be in a certain sequence and time order. So that's a consensus it provides. And also because of the cryptography technology with the hash, each transaction lumped into one block, and each block will be referenced to the previous block. That created that give immutability for the whole network. And provenance can be provided because now you have the time series of the change of ownership of that asset that you try to look for. And at the end, of course, with the trust on this ledger, it will be reduce a lot of risk in terms of being attacked and security-wise. So basically, the benefit is simple, right? Save times, reduce risk, increase trust, and then it can remove costs. And whenever there's any disagreement in the transaction, it will also that's actually more the increased. Because of the trust is increased, now everybody know the ledger is the same. They can just look back. It will reaching the reconciliation stage will be much faster. So going through the difference with and without blockchain in a business network, I wanted to switch gear into talk about some successful project out there. It's already going into a very mature level. TradeLand, it's one of the popular one that I think people might have heard of. Actually, it's started by IBM and Maersk a few years back. They started to work on blockchain to see how they can solve some pain point. And the pain point is like there's like 16 trillions of goods are shipped across international border. I'm not sure if you know, like 80% of the thing that we're wearing, that we're using, will be some point in time actually in the ocean carrier. Going from different country to different country. So it's a huge market, but it's a very paper-based, highly manual process. So before blockchain's being applied, moving the container, the administrative cost to move container is actually higher than physically moving it. So it's a lot of ways in this process that we can do something about. So it makes it a very good use case for blockchain. So by applying blockchain for all this good quality that it could provide, with the 1.8 trillion annual global market, it can already have around 10% saving of the 1.8 trillion when we apply blockchain. So that's what they have done. Last year, they announced TradeLand. And at the beginning, I would say, if you follow the media, the platform was not very successful to begin with. IBM and Maersk were doing it together. However, there are a lot of discussion need to go on with the multiple company, IP, and all the thing. So there's some lesson learned that like throughout all this process of making a platform that IBM and Maersk have worked together. And things change, right? As time moved on, we keep working on it. We know this is a good return of like helping this industry. So early this year, July, we have 2 more signed up from the ocean carrier, big giant ocean carrier that signed on to this platform to use. And it made it up to more than 50% or 55% of the global ocean carrier data is now running on that platform as of today. So this is one of the good examples of showing that there is that hype cycle. It goes through the similar hype cycle too. Like there's hope, and then we form it. We make the platform. People are not joining because they have hesitation, and then they go through the trough of a dissolution like phase, and finally people realize this is actually a true technology can help with this process. Another good one is food safety. I think it's well known that food safety, only 1 in 4 consumer today trust the food ecosystem we have. I think I have been a victim of food poisoning. 1 out of 10 people get sick every year because of food poisoning. And then the supply chain for food supply chain is actually a very inefficient process because of the farmer and the retailer, and all the whole process is very complex. So, and they're also very paper-based. So it's very inefficient. Food waste is another problem. 1 out of 3 fresh food is going to be thrown out, either because it might be ruined during transportation or for other reasons. Food fraud, I'm not sure if you know that. Every time you go to a sushi restaurant, the fish that you're having, it might not be exactly what that fish claim it is. A tuna might not be a real tuna. So 1 in 5, actually the data we got, it's a seafood sample could be mislabeled worldwide. So what can we do, right? So that's what we started our Food Trust platform. So IBM and Walmart back in 2018, maybe earlier actually, they started a proof of concept to track a package of mango and a package of meat, pork. So I'm just using mango as an example. So typically, when you have a package of mango in your hand, if somebody say, hey, something's wrong with this, can you track back where this came from? It will take 6 days, 18 hours, and 26 minutes to figure out. So it's a long time to wait, right? If you're not feeling well and don't know where it came from. With the POC that they completed, we completed, it's only take 2 seconds. So they did that. So since then we started to build this platform for food provenance. And Walmart last year, this time, wrote a letter to all their leafy green supplier, mandating them, actually, I should say, that by the time this year, in September, they should be working on getting their data onto the food provenance blockchain platform, so that they can fight E. coli outbreak or any food issue that might come out for food safety purpose. So this is another good example of a successful blockchain that a good use case. It takes time, but we're getting there, and the momentum is growing. There are many companies are joining also since then. So that's another good one that I wanted to mention. And I have a reason to show this one here because now coming back to a more comfort zone of me in the electronics industry, and many of you will belong to somewhere in this column somewhere, even though you might be just maybe you're writing code, right? But you will be part of this very complex ecosystem. Think of it as a package of mango. Instead of a package of mango, if a package of components in there, resistor, capacitor, put into making that DIMM, memory DIMM that shipped to a system integrator and ended up in the big cloud data center, right? So there are a lot of data silos in this very complex ecosystem. So another great opportunity to apply blockchain to help with our process. So our motivation in the IBM supply chain engineering organization that I'm in, our goal and our mission is to, just like anybody out there, try to think of like, is blockchain a good technology? We want to try and evaluate, is it truly blockchain a good one to help us to mitigate pain point in the supply chain? So I did not mention earlier, another role of mine, I have another hat that I wear. It's a counterfeit prevention in the supply chain engineering team. So I'm haunted by this lady all the time. From time to time, I will receive inquiry from government, like aerospace industry people asking the system that you shipped out. How can you ensure that your supplier is providing the component they're supposed to provide? How can you ensure that they're not being bugged with some device in there, eavesdropping, that kind of thing? So the question is very simple, right? Just tell me, how can you be sure? But to me, to answer that question, it can easily take up to 3 to 6 months, because I trust my supplier, but I don't trust my supplier's supplier, and not to mention there's a few more down that tiers. So in order for us to get a right answer, not getting ourselves into trouble, right? We need to go through all the investigation and provide all the documentation to prove that we did our diligence to make sure that. So that's why that's me there. And other potential pain point is that maybe all of you can relate. It's GDPR came in live last year, or maybe I'm missing 1 year. It's last year, May, right? And then there's also a similar data security related issue, will be more like data sanitization. How do we make sure a drive that failed from a data center that with information in there needs to be crypto erased? How can we ensure that when it come back, right, it's clean? So those are the pain point we have, because when a drive actually fail, if it cannot be communicate to execute the script to crypto erase, for example, for SED drive, then we basically need to crush that drive because there's no way we can prove that we did erase the data in there or the keys in there. Product recall, a very common one, when we know there's some defect on certain component that will affect the whole lot of component or drive. How do we recall it? The one common one is like sometimes I get drive back from the field and ask me to validate if this is our drive, and so it always like costs time and go back to the database that we have to make sure that it is truly our drive. So I won't repeat a lot of the good quality of blockchain that might help to tackle the problem that I mentioned earlier, but basically it's really because we have the shared ledger. If we apply blockchain to our end-to-end supply chain, then we can be able to go back and say, hey, this is actually truly a drive that come out from this supply chain. If there's defect, we can utilize the data going to be written on the blockchain, be able to do some analytic, maybe recall the whole block of affected drive very quickly, like the Mango, right? And then transparency. I don't know what my subtier supplier is doing, but with blockchain, if we incorporate them, then that will be a good way to have improved transparency for the whole supply chain. And then not to mention that when you have trust, the inefficiency of the process will be eliminated. So getting into a little bit more detail into exactly what the proof of concept that I working in my organization with the storage supplier doing. One weak point we have in the storage device, as I mentioned, we trust our supplier very well. We work with Seagate, we work with Toshiba, or like all the storage supplier, right? We trust what they gave us. The problem is the egress of counterfeit is actually really coming back when it's in the reverse supply chain. So the reverse supply chain is really when a customer call up IBM, like the CE, our customer engineer, say, hey, we have a defect drive. Can you come and can replace it for me? So they will go out to the field with a new drive in hand, with a replacement drive, a full drive, go there, replace it, take the drive back. That drive would then start to enter our reverse supply chain. It goes through a lot of different warehouse, sorting centers, and then ended up going to a repair center that we contracted with. And then that's where it ended up found out that this drive is actually not made by IBM. It's actually coming from probably somebody somewhere at the customer side or at our business partner might have inadvertently bought something from the internet to replace a drive from the past or did something, right? When they bought it, they might see IBM 11S barcode and they thought they're real, but ended up it's actually not. So that's a POC we did try to prevent that from happening. And that's the envisioning of how the ecosystem might look like. with the hard disk drive provenance that we did on the POC actually. But that can be also applied for SSD. You saw the earlier complex end-to-end supply chain. So we cannot boil the ocean, like I mentioned early on. When you do your first POC, you need to scope your process. So this is what we ended up with, and I did get the approval with Seagate to publish this slide. We ended up with deciding the genesis of blockchain. We put it, the first block will be Seagate, our drive provider. And they will be providing the birth certificate, the needed attribute to the first block. And as it goes into IBM, the change of ownership of that asset will be recorded, and so forth. So we do have an application for this. We demonstrated in the POC that when the CE, customer engineer, go to the field and return the drive, get the drive back to from the customer, they will be able to look up on the blockchain, which is an open blockchain, to check if this drive is truly come from our drive maker. So there are some other examples that I'm not going to go detail into what we have also done, looking into blockchain, evaluating it, applying it to supply chain. With IoT, we put IoT sensors into our shipment to see if we can be able to improve trust into this process of when it get out from our door, when it get to our client, what happened in between? Has it been dropped very hard that it caused damage and that kind of scenario? And we also have a POC completed for custom declaration to help to improve the process. So this is coming to the last slide. Basically, with all this lesson learned in this past year, we work with our supplier on the blockchain. We do notice that no matter what blockchain project you worked on in this world, we need some kind of data exchange standard. Just like the food safety example as well. They actually have the blockchain designed for GS1 barcode standard to put the data on the blockchain. So what do we have for the electronic world in equivalent? We do have traceability standard published by IPC 1782 about a year ago. I think there's a SAMI standards working. I know this is not a standard calling meeting, but for SAMI, they are working on the traceability for single device standard as well. So the lesson learned is that we know as we move from the POC into pilot mode, we need to also work closely with this standardization standardization organization to make sure that we have a standard in place so that more participants in the electronics industry, not just Seagate, but maybe other drive maker or device, storage device maker can also join into the same platform, be able to track the asset. So that's basically summarizing the talk that I have today. I would say it's a very simple key to success is really need to collaborate, no matter if it's your business partner, your competitor, or with a different organization to make blockchain work. Thank you.
Any questions for Michelle?
In the case of the food tracking of blockchain, food provenance, what role, if any, can the government play in terms of making that happen more effectively?
I think right now the government doesn't have a role in there yet. It's almost like the process of implementing blockchain. We need to scope it. When we have the participants join together, we usually don't start including the government as one of the user. But for the food trust wise, they can actually see the data, right? So then it will already help them to be able to check for the regulatory purpose. But I don't think it might be the way that we're trying to drive to for the government to come in and dictate, okay, all of you need to get on the blockchain. That's not what we're working on right now from my.
But if the FDA was to mandate that, because they have to face the problems when something goes wrong in the supply chain, wouldn't that be something that would be beneficial for everybody?
I would agree. So hopefully we're going into that direction with more and more participants coming on board. that as it mature, I think it will be a good, it may be eventually, it could happen, right? But at this moment, I think with the maturity of the technology, it might not, we're not there yet.
Okay, thanks.
All right, thanks, Michelle.
Thank you.